Okay, so whilst we're here on the stand with our lovely JCB 403E, we thought it'd be a great opportunity to have a look at the three-phase motor current alongside hydraulic pressure. So with three-phase motors, there is a section in the electric vehicle guided tests. So electric vehicles, system and components, and then we have motor winding current phasing. We're going to load the guide and settings file, which will obviously help set up the scope in the background and obviously configure all the channels. We get the information about the actual test, how to actually carry it out. So underneath the vehicle, which will try and add an extra shot in here so you can see how the clamps are connected. This vehicle does have the phases that are individually cabled, so we can easily get a current clamp around them. I appreciate not every vehicle is that easy to get to. However, in this situation, we do have that opportunity, so we're going to take it. We're going to minimize the guided tests, and we have our waveform on the screen. As you can see, everything is configured on the left-hand side tool panel. So we've got channel A, B, and C all selected to 1 kiloamp. They are using the BNC Plus times the BNC Plus current clamp, 2000 amp clamp, which when we start the software, you'll be able to see as it connects. So let's run it. Hit the status button to change the status to running. And as you can see, we have our 2000 amp clamp, 2000 amp clamp, 2000 amp clamp. Happy days. Now, currently at the moment, channel C is also configured for a ×1 lead, but we'll get onto that in a second. So if we can just increase the pump speed, so we're gonna operate the arm to take it all the way up in the air and actually just load it at the top. So Simon, when you're ready.
Ready?
Ready, go. Excellent, thank you very much. So with the waveform captured, we'll go back a buffer and we have our waveform. So now we can actually, well, first thing we want to do with anything we're doing with Pico is save it. So obviously on the top tool panel or within the menu itself, we're just going to go ahead and hit the quick start button. Save the file, we're going to rename that. We're going to call it motor current. We're just going to save everything, and we could fill out the rest of the information. I mean, we'll do a quick one. We'll just do off highway and electrical, and now we can see a small little tip here. Obviously, if you're going to select the vehicle information on the right hand side, do that first before changing your file name, because it will overwrite it. Hit save. We'll go ahead and save the file. Right, great. Now we can start actually looking into the file and looking at a bit more of the details. So we'll use the zoom feature. We'll zoom in around our phases, and what we should start to see is a rather lovely little picture where we can see our three phases as how they're operating. So different elements to it. Obviously, we're looking for uniformity. With a three-phase motor, we want each of the windings to pull the similar amount of current across each of them. There is some odd stuff going on here. Is that a problem? Is it a repeating event? It isn't repeating, which could indicate that it may have just been a moment where the current was slightly different. So would it be a problem? Something to look into, maybe. I wouldn't necessarily go down the route of trying to diagnose that problem. Okay, what we're going to do now though is actually we have the electric motor connected to a hydraulic pump. So now what we want to see is the relationship between the electric current being pulled by the motor in order to operate the hydraulic system. When the arm of this machine gets to the top, we are going to hold the arm over, so we're putting the maximum load onto the hydraulic system. So again, we can see during this section here, what was our maximum current? Well, let's just drag a ruler down roughly. It's around about 600 to 650 amps, quite significant. So how does that relate to the maximum amount of pressure? So what we're going to do is we have WPS 600 connected to the machine and the pump underneath. We have the WPS set to range 600 bar. It's on, ready to go. Connected to channel D on our oscilloscope, but it's a non-BNC Plus probe, so that does mean we have to configure that channel in order to make sure the units are correct. So under probes, scroll down to the bottom to find our pressure sensors, WPS 600 bar. It's important to make sure that they match between the software and what's selected on the probe itself. Now, we can look up the spec as to the maximum amount of pressure on this machine. We're going to go for 0 to 300 bar because it's around about 200 bar, but it might go slightly above that. So we want to make sure that we capture everything as best we can. Okay, so we're going to start the software again. The guided test actually automatically put a trigger in place, and we're just about outside of that. So we are good to go and start again. So when you're ready, please, Simon, just lower the arm slightly and then bring it back up again. Perfect, and then back up. Hold it there and let go. Perfect. Okay, so again, we want to get that saved, make sure we don't lose anything. So again, if we wanted to do, in this situation, off highway, electric, yeah, and I'm just going to hit save on that. Make sure it's saved and then it can't go anywhere. So now we have everything on one screen. We have channel D highlighting the difference in pressure as the hydraulic system was loaded. We can see how that relates to the current flow. So at this point where we have maximum pressure, we have maximum current. So they are directly linked. If we start to actually add some measurements in as well, so we're going to hit measurements. For channel D, we want to see what our maximum pressure was. So we're going to hit maximum 188 bar. Yeah, quite considerable considering it's actually just an electric motor. A little tip, if we wanted to make each of the channels a little bit more visible, under views, hit auto arrange, and it will separate each of those channels out so you can visually see how they all work together. Last little test we're going to do. You may have seen somewhere on the forum and on our website called the XY. So XY, or the Martin's method, as Mr. Steve Smith kindly renamed it, allows us to plot channels against each other. So where we have our three phases of current, we can actually plot them referenced to an individual phase. Why is that useful? Well, it's just a better visual representation of what's going on with each of the phases relative to one another. So, in order to do this properly, we're going to drop our time base down quite considerably. So, going to be around about 20 milliseconds per division. We're still going to add our trigger in, so we'll keep that at 10%. We can get rid of channel D, but we are going to add in the views. So under views, XY, we want to put 3 of those on. We have 3 phases, 3 XY views. Now, obviously they're quite small and square, so we can actually change the aspect ratio. And what we'll do is we'll actually just make use of the fact we can manipulate these screens a little bit easier in PicoScope 7 now. So I'll put that one up there, and that one there. We'll start the software. And hopefully, we're obviously not going to see any data because we are in the repeat trigger mode. So repeat trigger, anything in streaming, so 200 milliseconds per division and above. Anything under that, into auto. Auto will show you something. So even if you haven't got your trigger quite correctly set, you will still be able to see what's going on. So we want XY1. We're going to have channel A as our x-axis. And we're going to relate channels B and C to that. XY2, we're going to use channel B as our reference, and then reference A and C to that accordingly. And obviously channel, the last XY very Fury, we're going to reference to channel C, and obviously A and B are now our references. Okay, so immediately what we can see is there's this kind of weird shape that's happening on the screen. Now, might not mean an awful lot at the moment, but visually it's helping us quickly relate each of the channel or each of the phases to one another. Now, if we increase the load or increase the current draw from the motor, we'll see those shapes change. So, Simon, if you can just load the machine for me. Perfect, okay. I'm going to stop that there whilst it's still on the screen. And now we can see that those images are now very, very different. But what we've got is uniformity between all of them. Should a phase be incorrect or there be a problem with one of the phases that's just affecting obviously one, we should see how it relates to the other ones and how there could be a possible issue with it. So it's just a visually different way of viewing those 3 phases when actually looking at them in the time domain might not be that clear. All right, so I hope that helps. I hope you enjoyed, and come back for more, and we should be doing some more tests on this later.